Hello students, welcome to the 11th video lecture of Digital System Design subject. In the 10th video lecture, we discussed about binary multiplier. Today, we will learn about magnitude comparator. So here we are going to study about 1-bit magnitude comparator. It is a combinational logic circuit with two inputs A, B and three outputs are like A is less than B, A is equals to B and A is greater than B. So it compares two single bit numbers A and B and produces an output that indicates the result of comparison. So we need to remember these three conditions which will be in the form of output. So let's begin with truth table. As you can see, we have inputs in terms of A, B, and since we have inputs A, B, so we can have four possible combinations 0, 0, 0, 1, 1, 0 and 1, 1, right? For producing the output, let me take first case y1 equals to A is less than V. So A is less than V, as you can see, for these two values, since both the values are equal, these two values are also equal. That's why we are getting 0 as a output. Why? Because our condition was A less than B, but these values are not less than with other. In fact, these values are equal to each other. That's why we are producing 0 output for corresponding to these values. Also, with this case 1, 0. With this case, let me take another color. 1, 0. So A is not less than B. That's why we also taking 0 as a output. But for this yellow marked value 0, 1, as you can see, A is 0 and B is 1. Of course, A is less than B. That's why we are taking 1 as a output. So this is the way how to generate the value corresponding to input. Let me take second output y2, A equals to B. So for A equals to B, as you can see, these two values are equal in terms of 0, 0 and these two values are also equal in terms of 1, 1. That's why we are taking output as a 1, 1 because it is satisfying the condition. But for the remaining values like 0, 1 and 1, 0, the outputs are 0. So this is the way to find out the output for A equals to B. Let me take last case where A should be greater than B. So as you can see, A is 1 and B is 0 for this particular case, and which is greater than B. That's why we are taking output as a 1. But for remaining cases marked with yellow color, for remaining cases, the conditions are not satisfied. The condition is A should be greater than B. That's why we are taking 0 as output, right? After doing this, we need to make K-map. For this particular column, as you can see, K-map will be 0, 1, 0, 0, and after solving this particular K-map, it will give you A bar B. For the second column, we can form K-map like 1, 0, 0, 1. After solving this K-map, we will be having A bar B bar plus AB as an output, and which is also equivalent to XNOR gate. For third column, we are having 0, 0, 1, 0, and after solving, it will give you AB bar. So these are the three output: A bar B, A XNOR B, and AB bar. With the help of logic circuit, we can produce the output. So as you can see, in case of this particular logic circuit, y1 is produced in the form of A bar B. So as you can see, the connection y2 is produced in the form of a XNOR b, that's why XNOR gate is there, and y3 is produced in terms of a b bar, that's why as you can see the connection. So this is the circuit for 1-bit magnitude comparator by which we can compare 1-bit binary number. Thank you.